Welcome aboard the Tech Genius XY channel. Don't forget to hit that subscribe button and ring the notification bell for your passport to programming in English and Hausa. Thank you for joining us today. Our topic, we are in lesson 3. Our presentation for today is continuation of the previous lesson. So if you are new to this channel, please kindly go back. If you are still want to go to the root of the Python, check our previous videos, which I'm going to add the link in the description. So we are going to proceed with Python's int data type, which is one of the most used data type in Python. So we are going to check the syntax, the semantics, which we say syntax is the valid combination of Python's symbols, and the semantics is the meaning of the combination. How does it, the logic of that is the semantics that Python use. So we are going to check the conversion and other method for int data type. So what are you going to learn in this presentation? In this presentation, we want to ensure you have good understanding of Python's data type, including conversion from different base 10, base octal, base 8, base 16, base 2 binary. And we are going to ensure that you know how to carry out some operation, arithmetic operation, bitwise operation, and Boolean operation using the int data type. So now, how does the format of int, how does it look like? So I'm going to use my mouse to indicate this int x. It stands for integer. And what is integer? Integer is all positive number including 0 and all negative number. So integer does not contain decimal. So that is the definition of integer. Also in Python, the same apply. So now this is for this example, int including two brackets, then in between the bracket we are passing is quotation, and we know quotation deals with string. So quotation, then a number inside, which is 10, which is an integer number, but because it's been in quotation, it's no more integer. Python will look at it as string. So we want to convert this string to number, to integer, that is to positive number 10. So that is by calling this function int integer, then we write whatever we want to convert is going to give us the output 10. So, and if you want to change this 10 to binary, you just have to call the method, which is bin, then pass it in brackets. You pass the value or the variable that you want to convert to binary. The same thing to hexadecimal, the same thing to octal, that is base 8. Or if you want to customize your own base, you can advance further. So that is basic about that. Let's proceed. The mathematical operation, we are going to see that in the interactive window. So let's jump to our interactive on the online IDE. This is our replay. So I will advise, even if you're on your mobile phone, you can as well log into this website and try and run this code yourself. So the first code here, I'm using the commenting to give additional information of what we are dealing with. So in this case, this hash is single quotation, single commenting, sorry. So we are commenting, we are telling whoever is checking this code that this is, we are declaring int variable. So, and this, we talk about how to declare variable. This is a positive, this is a negative, and in this place we are carrying out, don't forget, this is we are dealing with integer data type. So we are carrying out the arithmetic. This is the plus, the negative, just like your normal mathematics, the division. But in this case, we have two division, that is two slash slash, We call that floor division, as you can see here in the commenting. So what does it do? It has to return the nearest whole number. It's going to round up the nearest whole number, the floor. So we are going to check, we are going to print that to ensure that at that side what is really happening. So let's do that real quick without wasting time. So, and what I want you to take notes, I'm using the same name to store all the remaining values. So what will happen at this line, if I put the print function, it's going to print the value 13. At the second line, if I put the print function, it's going to override the first one. That means the first one will not is not going to get we are not going to get the answer of that one. It's going to be out of the memory. So because we are redeclaring the same variable with the same name with 10 minus 3, that is going to give us 7. So instead of the result should give us 13, it will give us 7 because we are using the same name. So if you are using the same variable more than one, that means the first variable is going to get, or it will be overwritten. It's going to get override by the second variable. So you are not going. So that is one of the naming convention that you must be conversant with to avoid overriding your previous variable. So in this case, this is just for purpose of presentation. So I'm running this. I want to see the result, which is in number 11, which is 10 floor division 3. So let's see 10 floor division 3. We are having 3. So as you can see, that is is returning the whole number. So if you check your calculator, you do 10 divided by 3, it's going to give you 3.3. In this case, is only returning the whole number. That means it's going to round up the nearest whole number without the decimal. So while the second result here, the last result, the module is going to return the remainder. So I'm going to cut this print function and bring it down because we know it's going to get over. We are going to override the results. So this will be the last one that will remain in the memory. So all the remaining one will get out of the memory. So this is 1. So the remainder is 1. That is what is happening there. So in this case, we want to convert floats to integer. So we call the int, then we pass the number, the float number. We know float is any number that is decimal, whether positive or negative, as long as it has decimal in between, is a float. So by converting this, we are changing the 3.5 to float. So let's still use this print function to let's cut it and bring it down and paste it so that we pass the x. We are going to pass, instead of result, we are only going to pass x to see what is really happening. So we are converting, is returning the 3 without rounding up the number, or it doesn't round up the number 3.5. So it's just returning the first whole number in that case. So you have to take note of that. So, and the second one, which is y, we are going to cut the same print function and let's print it under the line y. Then let's change this x to y so that the output will only be for y. So let's run this command. 42, you can say this is string, but it has converted to integer, which is 42. So that is the first line here. So that is basic about that. So in the second, the bit count here, our variable, we are using method bit length. We want to check the length of this bit in terms of binary. So let's print that and see what is going to happen by calling the print function. So in this case, I'm going to copy the variable name and pass it to the print function. So if you are printing a variable, you just have to pass the variable. You don't have to put it in any quotation. So I've run this. So 6 is showing 6, the bit count. The bit count is 6. So it counted the length of the the binary representation of 42, that is 6. That is what that means. It's not it's not showing. It will show us the bit, but instead of getting the bit, we are getting the length, because that is the method that we call dot bit length. So some method, you have to period, that is x period bit length, that is the dot we call it period. We are like amending the inputs of that to the output of the other one. So that is in Linux we use piping. The same thing goes to that dot. So basically that is all the rest are also the same thing. So I'm just going to continue explaining since we know how it works. So the int method, in this case, we are also calling to byte. We are checking the bytes, and this one will pass the byte length and the byte order. So then we'll print out the byte representation. You can check the rest of the documentation, Python's documentation for int data type to have more details, or you can be hovering around to read from the online, just like this one. It will show you the object that is taken in the parameter. So now we want to convert this binary, this decimal, which is 42, we want to convert it to binary. We are creating another variable, binary representation of num. Then we call the bin, which stands for binary. Then we pass the variable that we want to convert to binary, which is bin. So if you check that, you are going to see the binary representation of 4422 is this. So okay, this is the one that I was printing. I was printing this. I didn't print the 42, so I was printing this one. And how did I print it? I use this f strings, that is f format string. So there are so many ways to print in Python, but this is one of the convenient one and the easiest one to use. So the octal and hexadecimal, the same thing. You call the oct, then you pass the variable or the number that you want to convert to the octal, from base 10 to octal. That's what we are doing here. Then we are storing it in this variable octal representation, and this one is hexal, that is hex. We call the hex, then we pass the number that we want to convert, which is base 10. Then we saw this in hexadecimal representation. So that is, then we print this using the f string and the print function. So this is f string. We are formatting. This stands for formatting. Then you put the double quotation of octal representation or whatever you want to print out. Then this curly braces that we are passing the variable num is a placeholder. It's going to get replaced. It's going to be substituted when execution. So, and this octal representation is also a placeholder that is holding the variable here. Is going to get substituted during the print function. So that is basically the same thing as the rest. So in this case, we want to custom base conversion. Like we said, int data type itself, it can contain it has two parameters. It contains x and base. So that is the standard of int. So x stands for the whatever number you want to pass, then the base, what base that you are going to pass. So in this case, we are passing a binary but in form of string. That means it has to be converted to int first, then it will be converted to int, which is 10 10 10. Then from there it's going to change to base 2. So if we print this, we are printing it here using the f string and the print function. So we are going to the decimal value. So let's locate the decimal value. The decimal value for 10 10 10 is 10. So this is the binary representation and this is the decimal value. So for us to ensure that everything is going correct, that is how why we are printing all this here. So let's quickly go and finish our presentation here. So we have talked about this method, the mathematics, the converting of string. We also talk about the floats. We also talk about in this case, I would like to talk about this is numeric before calling the int function. This is for error handling. Is very useful Once we reach the application too, we'll talk more on that. So that is basically about this presentation. Thank you for coming, and this is the final assignment. I would like you guys to try your hand. Like I said, it's corresponding to the lesson objectives, objectives of this presentation. So you can read. I will drop the details and the description of this video. Thank you. Have a good day.